We now discuss the solution of a problem from the section Matrices and Determinants. The problem is related to finding the infinitely many solutions of a given system of non-homogeneous linear equations. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, if the system of linear equations 2x plus y minus z is equal to 7, that is the first equation, x minus 3y plus 2z is equal to 1, that is the second equation, x plus 4y plus delta z is equal to k, that is the third equation, where these delta and k are real numbers. And if this system has infinitely many solutions, then delta plus k is equal to, we are given four options. Option A, minus 3. Option B, 3. Option C, 6. Option D, 9. We are given a system of linear equations. In these equations, we see delta and k, and it is given delta and k are real numbers. And if this system accepts infinitely many solutions, then required to find delta and k and required to write down delta plus k. We now discuss the solution of the problem in detail. We take these three equations in three unknowns x, y, z, and which is a non-homogeneous system of linear equations. For this, we write down its matrix equation. It is written as Ax is equal to B, where A is called the coefficient matrix of the system, and A is equal to the coefficients of the first equation. The coefficients of x, y, z you have to write down 2, 1, minus 1. That of the second, in the second row, 1, minus 3, 2. That of the third, in the third row, 1, 4, delta. Capital X is equal to the set of unknowns, the column vector x, y, z. Capital B is the column vector of the constants, given 7, 1, k. Agreed. Now, it is given that this system has infinitely many solutions. This implies delta is equal to delta 1 is equal to delta 2 is equal to delta 3 is equal to 0. What is delta? Where delta is the determinant of A. Take this matrix A, write the determinant of A, that is delta. And what is delta I? Delta I is same as the delta with its ith column. That means the ith column of delta is replaced by the column vector B for I is equal to 1, 2, 3. Then you will get delta 1, delta 2, delta 3. Agreed. Now first we take delta. Delta is determinant of A. Determinant of the matrix A. That is the determinant of 3 by 3 determinant, whose first row 2, 1, minus 1, second row 1, minus 3, 2, 1, 4, delta is equal to 0. Is equal to 0. Expanding this determinant by its first row, then we get this one. We are very familiar, and is equal to 0. We are familiar about the expansion of the 3 by 3 determinants. And simplify, you will get minus 7 delta minus 21 is equal to 0. This will give rise to delta is equal to minus 21 by 7, that is minus 3. So thus we have obtained the value of delta. Delta is minus 3. We continue in the next slide. That is the story so far. Now we take delta 1. delta 1 is the same as delta with its first column 2 1 1 is replaced by the column vector b 7 1 k, which are shown in the red and delta 1 is equal to 0. Expanding this determinant by its first row, we obtain this is equal to 0. Simplifying, we will get k is equal to 6. Thus, delta is equal to minus 3 and k is equal to 6, required to find the value of delta plus k. So, therefore, delta plus k is equal to minus 3 plus 6, that is equal to 3. Let's look at our options. Our answer 3 appears against option B. Therefore, the answer to this question is option B. So that is the detailed discussion of the solution of the problem from the section Matrices and Determinants, which is related to finding the infinitely many solutions of a given system of non-homogeneous linear equations. And it is a very simple and straightforward question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.